Hello friends, welcome to a new video of Java online course. We are coming across one more important point from Java point of view, which is having the similar importance that of interface concepts also. Okay, a similar importance of the class concept also, and that is called as the class. Interface is the Java's most important concept where abstract class implementation can be done. We have seen the abstract class already. In the same way, the concept of interface is used here. They cannot be instantiated. The interfaces can't be instantiated, means their object is not created. That is, using the interface we can specify what class must do, but not how it does it. It's just similar to the one that we have seen for the abstract classes. Interfaces are syntactically similar to classes, but they do not have instance variables, and their methods are declared without having any body. Okay, so they are similar to classes, but they do not have the instance variables. Variables are present, but these variables are static and final. Okay, they do not have the method implementation also. They are having abstract methods only. This means that we can define interfaces which don't make assumptions about how they are implemented. Okay, once the interface is defined, any number of classes can implement that interface. Also, one class can implement any number of interfaces by creating the illusion of multiple inheritance here. Okay, now what do you mean by how to create that interface here? See, the definition of interface is the keyword which is used to define the interface here. Okay, so definition is like access specify, means either public or default, then interface and interface name. Interface name also follows the naming convention similar to the classes, like first letter in the interface is always capital. Okay, and internally we are having methods like return type, method name, and parameters semicolon. This is what we call as abstract definition of the interfaces. Okay, so multiple such methods are possible. Then data types, data type, variable, and value. Okay, so any number of such methods and variables are present. The difference is that the methods in the class are having definitions, but methods in the interface are without definition. They are abstract methods. And variables inside the class are called as instance variables, which separate copies created for every different variable, every different object. But for interface, these variables are always final and static, means their separate copy is not maintained, and these values are already fixed when you declare the variables inside the interfaces. Now let's see the example of creating an interface. So for example, I have created an interface here, interface college. Inside that I am having the strength of students, like 120 is the strength, total number of students are present. Void play is the method that I declared. Int count up, this again a method I have declared here. These are the abstract method which are declared there, and this is the constant which I have declared inside the given interface. Now what's the application of the interface here? Now interface can be implemented by other classes. Implements keyword is used to implement that. So once it is implemented, all the constants and the methods inside the interface will be available for the class who implements it. Which one? Now see, class my college is the name of the class, implements college. So college is the interface which is implemented by this class. Now once it is implemented, now two methods which are declared over here, their definition should be written in the class. Okay, so void play, so public void play will be something like this, and int count up will be public int count up will be declared over here. So their definition, these are the abstract methods, and their definition we need to write in the class we implement that interface. So first method, and this is second method which is implementing the particular interface, we need to write it. It is compulsory. It's not like we have to write or don't write. It's compulsory that this definition should be present over here. Okay, and the constant variable which is declared over here, I can use that directly inside the class who implements the respective interface here. Okay, so that's how it's required. Interface is declared and we have to implement that interface. Once it is implemented, it's required to write the definition of the methods inside it. Remember, the class inheritance and interface implementation, these are the two mechanisms used in advanced Java to create our own classes in respective Java technology. So when you have to create your own things, we need either we extend the class or we extend the interfaces. Okay, that's what we do. So let's see the properties of interfaces first, one by one, by 5 different programs. I will be showing it over here. See, the first program, that is the my interface dot java. So let's go for the interfaces. Okay, so my interface, where is that? Yes. Okay, so here I declared one interface called as the display. See this interface mango is the interface I declared, and it contains one abstract definition of the method. It's called as display method. And now this interface can be implemented by n number of classes. So first example, summer class implement the mango. So when it is implementing the mango, this abstract definition or this abstract method should be defined in this particular class. Okay, so public void display is showing first display only, and second winter class is also implementing the mango interface, which also contain the interface definition over here. This is compulsory, so we need to write the definition or the syntax of the method should be same, only the statement inside that particular method can be different. So here I write first dot display, first display, second display. Now so let's create it. So first of all, I am creating the object interface of mango, and we are assigning the object of summer there. It's just like superclass reference variable can store the subclass object. So here also I have done the same. This is what your superclass can be, just like interface is acting like a superclass, and its reference variable is m. Now winter n is the object of the winter class, and now I am using m dot display. Now first of all, m is containing the summers object. Okay, it's connected with its reference is there for summers object. So summers display method is called. Here it will show first display, and then I am assigning this object to the m. So to interface reference variable m, and then I am writing m dot display. So second time this display will be called. Okay, so this is how the methods are declared and they are reused. For example, if I change the definition of this method, I don't want this display method to be written. If I write display 1, you can check it. It will show the error. Summer is not abstract and does not override the method abstract method display in mango. So it is compulsory that you need to redeclare or define this particular method in the interface who implements it. Okay, and in this way, this is just like a method that we have seen, dynamic method dispatch, and one of the implementation of runtime polymorphism in Java can be done by this method. Okay, it was done by class method also, and possible by using the interface methods also. Okay, so in this way we do this, and the output of this particular code will be just like first display and the second display. So interface defined, implement it, and after implementation the method should be declared here in the class who implements it. Okay, so this is the way we are going to do it. Now let's go for some big program here, MultiInheritance.java, this one. So you just can check this particular diagram here. Okay, the things which are shown in the dotted oval, these are the interfaces, and which are shown in the rectangle, they are the classes. So player is extended into records, is extended into match, and this is interface IPL implemented by match, and this is information implemented by the match. So total 2 interfaces and 3 classes are present inside it. So this I am going to write, this I am going to implement in my program like MultiInheritance.java. Multiple inheritance like concept is used. So a simple small definition of classes and interfaces are used here. See how they are connected together and creating a multi-inheritance type of concept here. So first class is my player, where variable player is defined, and get name is to assign the name to this name, and put name is to print the name. Fine. Now this player is extended into the records class. So class records extends player. In records, 2 variables are average and s rate, strike rate. Okay, so which are declared by 2 methods, get data, by which first value is assigned to average, second value is assigned to strike rate. Okay, and put data method prints this data on the screen. After that, 2 interface I declared. First interface is IPL, which contains display earnings method, and second method interface is info, which contains the get team method, abstract method inside it. Okay, so their definition should be written in the class who implements it. Now see this is what implementation is. Class match extends records, implements IPL info. So 2 interface it is implementing by creating one mechanism, or just like multiple inheritance, 2 super classes and 1 subclass. So here 2 super interfaces we have used, IPL and info. Now records, what it happens actually when you extend the records, it means that now this player is extended into records and record is inherited into match. So everything available above, like name, get name, put name, average, strike rate, get data, put data, they are available directly inside this match class. And similar to that, these two definitions of these two methods from these two interfaces I need to write inside this class again. So let's see this. So what I pass earning, that's I've applied to earn variable here from the constructor, then display earning, the method from the IPL class, and get team is the method from the info class, info interface, which I have declared over here. So display earning is displaying the earning only in rupees, and get team is just printing the team name on the screen. Yes, that's how the complete hierarchy I have formed. One class inherit another class and two interfaces are defined. So all they are just used over here. Class match extends records, implements IPL info. Extends is not possible from multiple classes, but implementation of multiple interfaces is possible here in Java for a single class. Okay, so this is how the tasks are completed, the programs are created till this point. Okay, now let's see. So here I'm creating the constructor, or I'm creating object of the match class. So S, so here this will go and earn variable will be initialized. Okay, then get name. So here get name method is from the first class, which I'm assigning the name variable. Then put name, it will print the name like Shane 1. This will be printed on the screen. Okay, then get team. Get team is the method present over here, which is written over here. It is printing the name of the team, Rajasthan Royals. Okay, so s.get data. Now I'm putting the two things over here, that is average and the strike rate. Okay, get data, which are there, so they are present over here. So these two values are assigned. So avg and s rate will be defined now. And put data, so put data is just printing these on the screen, records, average and strike rate. Okay, that's done. And finally display earning. So whatever number I passed over here, this value is passed to the earn variable, and display earning, this method is printing earning on the screen. That's it. Okay, so this is how all these things are connected to each other. Basically not each other, the root, the lowest class, the deepest class, that is records, is containing information from the two interfaces and the two classes. And how can I make use of it? I'll create the object of that deepest class only, and with the help of that object I am performing operations of calling the methods and variables from the above interfaces and the classes. Okay, so if I run this code, you can check the output. See, name is printed by put name, then team is get team, records are by using put data, and finally strike rate on his earning is by display earning methods, they are printed. So this is how they are connected together, forming one concept of like multiple inheritance over here. So one class can implement multiple interfaces, but one class can extend only one class. Okay, so remember the requirement of the interfaces. When you implement the interface, their definition of abstract method should be present inside the class who implement that particular interface there. Okay, so this is how we have we have created the second program, which is given along with this video. You can try this, make the modification, and see what happens when you perform different respective operations on the given data. Okay, now there are three more properties that I will be showing in this particular video about the interfaces. First, interface can be written inside another interface. That's called as nesting of interfaces. So let's see this. Here I declare a class called as CPU. Inside the class I am writing one interface. See, public interface microprocessor. So this interface is microprocessor. Inside that I am writing a method called as is multicore, where the number of cores are passed, returning a boolean value whether it is true or false. Now the interface is declared inside the class. Now how to use this interface? If I want to use this interface, I can use the class name dot the interface name. Now I want to implement that. So class computer implements CPU dot microprocessor. So this computer class is importing the interface from the class CPU, okay, called as microprocessors. Implementing, once you implement this interface from a class, it's possible to write this definition over here. So I'm writing this definition, public boolean is multi-core. Remember, public is compulsory there because all the methods, variables that you write inside the interface are by default public. So when you implement the interface, that methods or variables should be written as public. Okay, so is multi-core, you return here if value of core is greater than 1, return true, else return false. Okay, so it means that when value are greater than 1, it is multi-core, and if it is equal to 1, it is single core, means it is not multi-core architecture. Okay, that's what I just want to represent out of this particular method. Getting? And now how to use it? Let's see. So I'm creating the object of the computer class, and I'm assigning this object to the reference variable of the respective interface, like CPU.microprocessor comp is equal to new computer. So that computer's object is assigned to the reference variable of the interface. After that, I declared one variable called as number of cores. So this number of cores I'm storing into the variable, and then I want to call the method like is multi-core from the comp object. So comp dot is multi-core, and then give number of cores. If number of cores are 4 here, it means that it will print it is multi-core. If it is not 4, it will show it is single core. So in this way we create the object along with the interface name, and this is how we are going to call the method which is implemented by the class. See, it is multi-core. Okay, so in this way I am going to call the method which is implemented inside the class from the interface. Now if I write 1 here, okay, so let's run this. Now it is single core. Fine. So in this way you are going to write the interface inside the class. So interface can be written inside the class by this mechanism. And how to use it? So in this way we are going to use the interface from a class, implement it, and write the definition of its abstract method inside the class. Okay, so this is how we can nest the interfaces inside the class. Second method, variables inside the interfaces. Now so variables inside the interfaces, see, I have declared some variables here. First property of the variables, many properties are present there. Basically the variables that we declared, they are not actually variables, they are constants. See the interface I declared over here, interface constants. Inside this interface I am declaring one variable or one identifier called as pi is equal to 3.40. This is a double variable there. Now this variable contains 3 properties by default. 3 properties are connected to it by default, though you are not written that. First property is that this variable is public variable, default. So there is no specifier like default, protected, or private there. By default it is public. Then it is by default static means so obviously interface objects are not created. Then how to access that? Interface name dot variable name. This method we are going to use it to access it outside of the interface. So by default that is static. And third, by default it is final also. See this, final means it should have the value connected to it, and its value can't be changed by any mechanism, that is it's a constant value there. Okay, so by default the variable that you declare inside the interface are public, static, final, and then data type is mentioned, then variable name and 3.14 value. Then string unit, one more variable I declared called as unit, which contains the unit name there. Okay, done. Then I am declaring one more variable called as values, where intcr equal to 2 is given there. And how to use these constants? So in order to use these constants, it is not compulsory to implement the interfaces, but if you implement an interface then also it's okay. But there is a difference. While implementing the interface and without implementing the interface, the variables are used in different ways. How to? Check it out. So here I am declaring a radius 5.83, and then I am printing the area of the circle by using the value of pi. Now interface var, this class is implementing constants. It means that these 2 constants I can directly use in my program. See, so I am using here pi and unit. Directly I can use it. Okay, so I don't need to write the name of the interface along with it, though it is a static variable or the final. I can directly use them by this particular method, system.out.print and pi and unit. So pi into radius plus unit, that will be the output, means 5.83 into 3.14, okay, into 5.83, like that's what the result will be getting. And to connect the unit to it, that is square centimeters. Okay, now I am not implementing this interface. Still then I can use these variables in my program. CIR. How to? So let's see. Perimeter of the circle. Here values system.out.println values.cir. So values is the name of the interface, CIR is the constant present in that interface, so which I am referring by using the interface name, then into pi into radius. Then perimeter of the circle will be printed. So that's what 2 pi r formula I am generating over here. But the difference that we are going to see here, if you implement the interface, you don't need to write the interface name. But if you don't implement the interface, still then you can access it, but you have to specify the name of the interface along with it. Then only the constants from the respective interface can be directly used in your program. So this is how the constants properties are present for the interface variables. So make sure that both interface constants and interface methods both can be present inside the interfaces. It's not compulsory that either method or the variables should be there. We can have both interface also, interface constants also, and interface methods also within the respective interface there. Okay, this is one of the property that we need to remember about it. And then the last property of the interface is inheriting the interfaces. So let's see how to inherit the interface. So extend interface. Okay, in this program I am creating two interfaces. Check it out. Interface SYIT, where the strength of this SYIT class is given as 68, and one method I am declaring there called as abstract method is display second. Okay, along with this I am declaring one more class. Okay, interface TYIT extends SYIT. Now interface extends interface. Remember, class interface class, interface extends interface. So when you are extending that, these two are available in this interface also. It means that now TYIT interface contains two implementation of strength. Two variables of strength are present there. Along with that, three methods are also there. First method is display second, second method is display third, and third method is display all. Okay, so they are also present along with this, and their definition also we can write inside the particular class who implements these interfaces. So how to do this? So check it out. So infotech, this is my name of the class who's implementing the TYIT interface. So TYIT interface is already containing two constants and three abstract methods. Okay, so when I implement that, I need to implement 1, then 2 and 3. Okay, so these three things we need to implement here. So total variable I've declared its whole instance variable is, then display second, which is printing SYIT.strength. So see how to differentiate between these strength variables from both of these interfaces. So SYIT.strength will print the SYIT strength, then display third here, which is implemented TYIT.strength, which will print the strength variable constant from the TYIT class interface, sorry. And display all, what I am doing, this total variable is containing addition of SYIT.strength plus TYIT.strength. So it's possible to use the interface name. Why? Because these variables are static. That's why it's possible to use the name of these interfaces along with it in order to use the constants from there. Okay, and then I'm printing the total on the screen here. Fine. Okay, so this is how the inheritance are connected to the interfaces also. And now if I run this file, I need to create object of this class only. So create it. X is the class object of infotech, then x dot display second, it will print SYIT.strength, and display third will print the TYIT.strength, and display all will print addition of both and print it on the screen. This is how the interfaces are connected and how they are implemented in another class. Make sure that interface, if interface is not implemented by any class, it is of no use. Okay, it can be used only when you have to use the constant variable directly in the program, that case only. Okay, it is not actually required in that case. So rather than using such values in class, we can in interface we can make use in class also. Okay, so this is how interfaces are connected together by an extension mechanism, like the inheritance mechanism there. So see, SYIT 68, TYIT 55, and total, this is what display all is printing the output on the screen. Okay, so this is the way by which we connect the interfaces together by inheritance mechanism. So one thing that need to remember, I'll just write it over here. Class can extend the class, fine. Then a class can implements the interface. Okay, then interface can extend interface. Okay, remember this. So these three connectivities are possible in Java programming language for classes and interfaces. Okay, there is no any other relation possible, like implements, like so what do we connect? Class, interface, class, interface. But interface class, first interface and then class. Okay, this is not possible. Means this inverse operations are not possible here in Java. So remember the use of extends keyword, remember the use of the implements keyword also. So how they are used and how they are demonstrated in the program. So all of this program which are shown in this presentation, they are shared with you. I just can try this program on your system and try to understand the concept of interface. We are going to use the default interfaces of Java's API for many different advanced Java technology very regularly. So it's acting as an alternative method to override the use of the classes. Instead of class, we use interfaces somewhere, and somewhere in interfaces we can use the classes also. Okay, so remember the properties of interfaces. We are going to use these interfaces very regularly in the upcoming sessions also. Thank you. Thanks a lot.